In a great place, in a place where people cannot understand, a silent revolution takes place. The tools we once relied on to reveal the universe's deepest mysteries are giving way to our understanding and revealing gaps in our planetary knowledge. It seems the fabric of reality is being questioned as new discoveries push the boundaries of what we once believed to be true. The Hubble Space Telescope, a symbol of scientific achievement, is at the center of this revelation, one that could rewrite the history of the universe. The Hubble Space Telescope, once the crown jewel of astronomical observatories, has come to a conclusion that is a little too far-fetched. Our understanding of the universe, and the physics that underlie it, is very wrong. This revelation is not the result of a single discovery, but the culmination of years of research, and finally a discovery that challenges one of the greatest scientific achievements of the 20th century, the discovery of the universe. Edwin Hubble, the astronomer whose name bears the Hubble Space Telescope, changed our view of the world in the 1920s. Using the 100-inch Hooker telescope at Mount Wilson Observatory, Hubble observed that distant galaxies were moving away from Earth, a phenomenon he attributed to the expansion of the universe. This discovery led to the creation of the Hubble constant, which assumed that the speed at which galaxies recede is proportional to their distance from Earth. This idea is the basis of the Big Bang theory, a model that has been central to our understanding of the universe for almost a century. However, as the Hubble Space Telescope looked deeper into the universe, it began to reveal doubts about the Big Bang theory. In the late 1990s, observations of the brightness of CFAS variables and Type 1a supernovae revealed differences in the values of the Hubble constant. These differences, now known as the Hubble, show that the universe's expansion rate cannot be determined uniformly. Measurements based on local events produce higher values for the expansion rate than measurements from the cosmic microwave background, the atmosphere of the Big Bang. The Hubble phenomenon is the first major challenge to the standard model of the universe, which is based on 6 parameters, including dark energy, lambda, and cold dark matter, CDM. This model, known as lambda CDM, has been the prevailing explanation for the universe's evolution since the Big Bang. However, the existence of dark matter and dark energy has never been directly observed. They remain theoretical constructs used to explain phenomena that current physics cannot. As Hubble's observations continued to defy the lambda CDM model, it became increasingly clear that something fundamental was missing from our understanding of the cosmos. The discovery of galaxies such as GN-Z11, which appeared to exist only 400 million years after the Big Bang, and the identification of objects like the ancient star, Earendel, which formed a mere 900 million years after the universe's inception, suggested that the early universe was far more developed than previously thought. These findings were perplexing, as they contradicted the timeline established by the Big Bang theory, which predicted that the first galaxies would not have formed until much later. The difference observed by Hubble was also confirmed by Planck's astronomers, who measured the microwave background of the sky, and found more differences with the predicted expansion rate. These observations led to the conclusion that the universe may not be expanding as Edwin Hubble thought. However, the expansion will be influenced by things we don't yet know and may involve new types of physics beyond the standard model. Enter the James Webb Space Telescope, JWST, the most advanced observational instrument ever built. Launched in December 2021, the network was designed to peer into the early universe, capturing the light of the first stars and galaxies formed after the Big Bang. However, what Webb has uncovered so far has only deepened the mystery. Instead of finding chaotic, newly formed dwarf galaxies and protostars, Webb's first deep images revealed a universe filled with fully formed, luminous galaxies that existed just 200 to 300 million years after the Big Bang. These galaxies, such as Glass Z13 and Sirius 93316, should not exist according to the lambda CDM model, which predicts that such structures would only appear billions of years later. Even more startling were the discoveries of supermassive black holes in these early galaxies, black holes so large that they defy current models of how such objects form and grow. The presence of these behemoths in the early universe suggests that either black holes can form and accumulate mass far more rapidly than we currently understand, or that our models of galaxy formation are fundamentally flawed. Webb's observations have shaken the very foundations of cosmology. The fact that we are finding mature galaxies and supermassive black holes so soon after the Big Bang suggests that our understanding of the early universe, and perhaps the universe as a whole, is incomplete. Some scientists now propose that the discrepancies observed by both Hubble and Webb could be explained by the existence of a previously unknown fifth fundamental force, one that acts on a cosmic scale and influences the expansion of the universe. This force, if it exists, would require a complete overhaul of the standard model of particle physics, which currently accounts for only four fundamental forces: gravity, electromagnetism, and the strong and weak nuclear forces. The idea of a fifth force is not entirely new, it has been proposed before in the context of dark energy, the mysterious force thought to be driving the accelerated expansion of the universe. However, according to Webb's findings, dark energy may not be as constant as previously thought, but may change over time. This is due to differences in measurements of the Hubble constant and differences in the universe's expansion rate. If dark energy is dynamic, then other fundamental constants of the universe, such as the speed of light or the gravitational constant, may also change over time. These revelations have a profound impact on our understanding of the world. If the lambda-CDM model is wrong, as evidence is mounting, then perhaps the Big Bang theory itself needs to be revised. The discovery of galaxies long after the Big Bang challenges the idea of smooth and simple creation of universe structures. Instead, it points to a more complex and dynamic world, where the rules we think about may change. As we enter a new cosmic era, discoveries made by the Hubble and Webb telescopes are forcing scientists to confront the limitations of our current theories. Hubble's gravity, the existence of ancient galaxies and supermassive black holes, and the potential difference in dark energy point to the need for new physics that go beyond the standard model and provide a more comprehensive explanation of the origin and development of the universe. What if everything we thought about the world was wrong? The tool that changed our understanding is what we are now asking. As the James Webb Space Telescope looks deeper into the universe, the discoveries it makes threaten the fabric of our current physics and suggest that a new, unknown force is involved in the universe. Of the world. Could this be the beginning of a new era in the universe, a place where the concepts of the past turn into the mysteries of the future? The implications of these findings extend far beyond the scientific realm of astronomy. They challenge our understanding of reality. If the things that govern the universe are not the same as before, it could change our understanding of everything from the formation of galaxies to the evolution of the universe itself. The power of dark energy, the mysterious force that accelerates the expansion of the universe, becomes stronger and changes over time and raises questions about the stability of the universe. Will the world be more complex and unpredictable than we thought? And if so, what does it mean for the future? This new ambiguity in our understanding of the world opens the door to other concepts that were considered fringes or fantasy. Concepts such as the multiverse, where our world is just one of many worlds, each with different physical laws, are bringing new attention to these phenomena. Likewise, the idea of a changing universe, in which the universe is subject to endless cycles of birth and destruction, challenges the Big Bang narrative. As we move forward into the unknown, the lines between science fiction and science fact blur, reminding us that our quest to understand the universe is always near. The observations made by the Hubble and Webb telescopes are just the beginning and point to a much bigger and more complex picture that we will see.